So good morning everyone. Good morning everyone. Can you, all of you hear me? Good morning everyone. Can all of you hear me, students? Am I audible to all of you?
Good morning, sir.
Yeah, very good morning. Okay then.
Yes, sir.
So today let us start with the continuation of the last class. Okay. So now can you see my screen? Can you all see my screen?
No, nothing. Yeah,
Nothing.
yes, sir. Now, now,
Now you can see.
yes, sir.
हेलो.
Blank, sir.
अभी भी नहीं आ रहा है.
Sir.
दिखाई नहीं दे रहा है.
Blank. Sir. Blank है सर ब्लैंक कुछ या व्हाइट व्हाइट सिर्फ पेपर दिखा हुआ है व्हाइट पेपर कुछ दिखाई नहीं दे
Sir, I'm sharing my screen. Wait. क्या हो रहा है ये? रुको एक मिनट रुको, मैं फिर से करता हूँ. मैं अभी सेम
ब्लैंक
नहीं आ रहा है?
स्क्रीन तो दिखाई दे रहा है मगर स्क्रीन ब्लैंक है
नहीं,
स्क्रीन
वो
ब्लैंक है
पहले की तरह पीपीटी नहीं दिखा रही है.
नहीं नो नथिंग सर नो प्रेजेंटेशन
हाँ, क्या हो गया? ऐसे तो होगा नहीं. कुछ एरर हो गया सर. एक काम करता हूँ. तुमको इन द लास्ट क्लास someone asked me regarding this one, na? What do you call it? In the last class, someone asked me regarding this one. In moment of inertia, why you take square of the distance? Yes or no? Someone asked me then the other day. So basic. Can you hear me, students? Hello. Yeah.
यस सर
Okay. So today is Ansari present. Ruhula Ansari is not there.
Sir, yes, sir, yes, sir, yes,
Okay.
sir.
I'm hearing you. So why do you take that one double times, right? So the thing is, remember, it is what moment of inertia is given by what one expression. Suppose F into R. Now look, moment of inertia basic concept is what? Suppose you are taking an x and y axis. Okay, Ansari, try to understand, huh? So if you are taking an x and y axis on the basis of a particular axis, when you rotate the object, the moment that exerts, that is known as moment of inertia. Now, hello. Now, can you send me the formula of moment of inertia, basic formula?
I equals to AR square.
Okay. A means what?
Yeah,
Hello. Wait. I'm having so much issues in network. So if I equal to AR square, can you hear me? Hello. Hello. Hello.
Sir,
सुनाई नहीं दे रहा है क्या मुझे?
hello, सुना जाए sir.
सुनाई दे रहा है. Hello. Hello. A minute. Wait. Give me a minute. I'm not able to hear any one of you. Everyone's network issues. अभी स्क्रीन दिखाई दे रहा है तुम लोग को? Can you see the screen now?
No sir, nothing.
Just
We can see nothing. कुछ भी नहीं है.
रुको. मुझे तो दिख रहा है. I am sharing the content to everyone. Why is it not visible? What about others? You can't see anything?
No, sir.
No, sir.
Now?
Same
Same.
thing.
Is it same now only?
Oh.
Is it same now also? So difficult, you know.
Yes sir.
अभी भी कुछ दिखाई नहीं दे रहा है?
नहीं सर, आपका नाम सिर्फ दिखाई दे रहा.
मेरा नाम दिखाई देने से क्या होगा? वैसे ऐसा ही दिखाता हूँ. Okay, then listen. I have to take the class also, no? I'll have to see if it happens again. So, I'm saying you just hear it today, huh? Hello? Hello? Again gone. Temazar?
We can hear you sir.
Okay. So, today I'm...
Can't see anything.
What? So, what is actually moment of inertia? Now, in that last class, we discussed like this, no? So, while finding out the moment of inertia, what we do? We take a small strip, right? So now we just take a small strip. Now look, we know what is the force of moment. Can you tell me what is the unit of moment? Can you say me what is the formula for finding out the moment?
I is equal to AR square.
No. Moment.
Moment of inertia.
I'm sorry. I'm trying to answer your question only. Just listen carefully. What is the unit of moment? Means what is the formula for moment? Can you say me? Force into perpendicular distance. This is simple. So now if force into perpendicular distance is there, okay, if force into perpendicular distance is there, then what happens? Then, you know, we have to find out force into perpendicular distance. Then you can write what? F into x, right? Now, if we write F into x, this, then what happens? Then F is the force and the R is the distance between the mass and the center. Now we know force is what? Directly proportional to acceleration, and the distance, suppose x or something like. So if that changes, then the acceleration will change. Then so what we can do is, we if we have to take the moment now, first of all we took one moment, right?
Now we can see, sir.
Now you can see. हेलो,
Introductions.
अभी दिखाई दे रहा है प्रेजेंट एक कुछ प्रेजेंटेशन स्लाइड?
Introductions.
हाँ हाँ ठीक है.
7.1.
Okay, good. Thank you, हाँ Damodar. Thank you very much. I think so this app is having problem. Okay, so now what happens? Look at these lines. We take what? The force into perpendicular distance, na? Then we get what? P into x. Now what happens? If we take the force into perpendicular distance, then this is the moment. So means moment means what? That force into perpendicular distance. Now if we have to multiply it again, that perpendicular distance from the line of action of the force, then it is called moment of a force, or second moment of force, or moment of inertia. Now look, I was telling you na, suppose a body is in moment of inertia, what happens? Suppose a body is about to rotate about an axis. That means what happens? I'm showing you a diagram. Wait, means I'm showing you an example. Suppose this is an axis. Now here is a body present, right? Now if the from the center, this one, there, so if this body is rotated like this, huh? So there will be one moment existing for that, and apart from that there will be what? One force that will be existing. Now for force, what happens? F equal to force. Huh? Now for that force, we can write the force equal to F or P. So there is one force present. Now we, for that force also there will be one moment. So for that reason only, for that pair we have to multiply it by one distance. Now for the second time why we multiply is, so that we have to find out the moment of the moment. That means what? पहले एक moment निकाला, उसके बाद उसका भी moment निकालना पड़ेगा. So what will happen? So we have to multiply it again by x. Now so what happens? It comes out to be f into x square. Now we can consider this. Look, sometimes instead of force, this force, the area or mass of a body is also taken into consideration. इसलिए हम लोग we write it as AR square or something like that. Now is it clear, Ansari? You had a doubt now? Is it clear?
Yes, sir. Yes, sir.
Okay, it is simple, huh? Now if you can see, in the last class we discussed about parallel axis, right? No, we discussed about which axis we discussed? Tell me. Parallel axis or perpendicular axis? Huh?
Perpendicular.
Can you tell me the formula?
Perpendicular.
Can you tell me the formula? This one was the formula, right? Ixx, Izz equal to Ixx plus Iyy. Yes or no? Huh? So this was the formula for perpendicular axis, right? Now we'll go for what? We'll go for parallel axis. Huh? So what to go for? Now look at the difference. In perpendicular axis, if states that if Ixx and Iyy are a moment of inertia of a plane section about two perpendicular axes meeting at O, look, Z, this Z and this Y, suppose they are perpendicular, or this Z and this X, then we use the perpendicular axis theorem. And for parallel axis theorem, what we do is, look at the difference. It states that if the moment of inertia of a plane area,
It's same, sir.
huh? What?
Same है.
क्या same है?
वही स्लाइड 7.1 इंट्रोडक्शन में ही है तो अभी तक.
अभी तक
Still
चेंज नहीं हुआ है क्या?
No, sir.
This is quite
Not for me. Not
What
for
about others?
I don't know
Is
for.
it changing for others? I'm just changing everything.
So same. We are still in
No, sir, no.
introduction.
I don't know what happens, what is happening, because in my one it is changing. But what happened to you? I am just totally clueless. I'm totally clueless. Wait. I don't know what is happening with the app today. Now is it coming?
Now it's blank.
Blank. Just wait for some time. When it comes, you tell me if it comes. If it doesn't comes, then just take out your copies and I'll just dictate you. I'll have to check it out what is happening actually in the problem.
If you have PDF, sir, send it to the group. I will share.
I have
Yeah.
the PDF of this book, but I'm doing numericals now. I'll send you to you. Okay, Temazat, you share with your friends. Okay, I'll send it to you.
Share also in your class, sir.
How to share? Means?
Your presentation I can also share. You can teach with that, sir.
Oh yes, that is very good. Yeah. Okay. Actually, okay, fine. You can share now, Temazat, in your laptop. अभी दिखाई नहीं दे रहा है कुछ?
नाम में अटका हुआ है. आपका नाम ही दिखाई दे रहा है. कुछ दिखाई दे रहा है.
Okay, fine. I'll tell you the theorem. Just write it down. Theorem of parallel axis, right? It states that if the moment of inertia of a plane area about an axis through its center of gravity is denoted by Ig, then I'm having serious network problems, I think. Then the
Now it's video.
visible
7.13.
7.12 theorem of parallel axis.
Now it's in 13.
13
Rectangular section. हाँ 13 में.
12 में नहीं आया?
Sir.
बोलो 12 में नहीं आया?
No, sir.
एक बार फिर से मैं शेयर करता हूँ. Can you see something now? Can you see something now?
Yes, sir.
You can see a what file?
No, numerical, sir.
Okay. So if I go to the bottom, can you see something in the bottom? I'm going to the bottom. IG1, something like that. Can you see something? Next page, the IG1 or something
No,
like
no,
that.
no,
No,
no.
sir.
You must send me a screenshot what you are looking at, watching. Okay. Okay, remember now. Let me keep on speaking. You just hear it. If you are able to see it, tell me. In parallel axis, what happens? Suppose if the moment of inertia of a plane area about an axis through its center of gravity is denoted by Ig, then the moment of inertia of about any other axis AB parallel to first and at a distance h from the center of gravity is given by IAB equal to Ig plus AH square. Okay, this is the expression for moment of inertia. Can you see something? Can you see something, students? Students, can you see something? Hello?
Yes, sir.
No?
Yes, sir.
जय मदद no. Not see. कुछ दिखाई नहीं दे रहा है?
तो हमको तो दिखाई नहीं दे रहा, सर.
बाकी को? बाकी लोगों को?
We can see it.
Now it's
Yeah,
we can see.
parallel.
Okay. Let me tell you. You can see 7.12.
Yes, sir.
Because of this network is going dull. Okay. So I will not move anything. Just speak to you about this. What is actually theorem of parallel axis? If you can see here, okay, when I draw something on the screen, can you see it or not? You just tell me. Okay. So see, if the moment of inertia, can you see these lines highlighting? Hello. Hello.
No.
Chalo, chalo. I'll leave it. So if you see this in 7.1.2, if the moment of inertia of a plane area about an axis to its center of gravity is denoted by Ig, then the moment of area about any other axis AB parallel to the first and at a distance h from the center of gravity, this is given by what? AB equal to Ig plus AH square. Can you see the formula? Can you see the formula?
Yes, sir.
Okay. So if you can see the formula, then look. Suppose if you see the figure 7.7, then IAB, AB, if you see the figure 7.7, A and B are two lines which are parallel. Huh? Now, if these two lines are parallel, then this circle, this is a circle, right? Figure 7.7. Now, this circle is having a moment of inertia G. So, this G, if you see the diameter is parallel to AB, yes or no? Now, if the diameter is parallel to AB, then we'll have to apply what? Parallel axis theorem. Now, if these two diameters are parallel to each other, then we have to find out what? IAB. That means moment of inertia about this line AB, this point AB. So moment of inertia about this point AB is equal to what? Iz. Iz means what? You have to find out the moment of inertia of the circle. So which is pi r to the power 4 by 64, I think, plus h square. A means what? That area of the circle. Area means what? Pi d square by 4, right? Or pi r square. So you have to find out the area of the circle and then you have to multiply it by h square. If you have to multiply it by h square, then what happens? That from the center of the distance, then from the center of the distance, these two distance are like from center it is z, na? From this z and AB. So that distance is h. So this formula is given by what? Ig plus h square. Okay, so this is the formula. This is the formula. Just remember the formula. Ig equal IAB equal to Ig plus h square. Okay, so this is what should be the formula. So now remember this formula. Now this, apart from this proof, this diagram is very important. Okay, so this diagram is very important. Now what happens is that if you are now if you are have to find out using parallel axis, so you have to use this. Now let us go to the numerical of the last class. Can you see the video?
Yes, we can see. But
बोलो
sir, your background is very disturbing us.
क्या क्या बैकग्राउंड हो रहा है? कुछ साउंड आ रहा है क्या?
आपका जो दुंग दुंग, हाँ बहुत आ रहा है सर.
बहुत आ रहा है. ठीक है. देखो पास में कुछ चल रहा है शायद. What is happening this? अच्छा सुनो. I'm very sorry for all these sounds and neighborhoods and neighbor work is going on. Okay. So can you see the word file now? Can you see the word file now?
Yes, sir.
Okay. So in this I section, in the last classes we discussed how to solve this numerical. So you found out this y bar, right? So this y bar is what? So you have to find out this y bar you found out as 60.8 mm. In the last class we found out. Now what you have to find is h. So what is h actually? H means the distance of the rectangle 1 from the x-axis. So how will you find out the distance? Okay, tell me the formula of center of gravity of a rectangle first of all.
L/2.
No, it's wrong. What is the formula? In the last class we discussed, na? Moment of inertia of a rectangle, then circle, then sphere. Oh, can you tell me, anyone? Can anyone say me? So it is what? BD cube by 12.
V cube by 12.
Remember? याद आया तुम लोग को?
Yeah.
So BD cube means what?
Yes,
B
sir.
is the breadth, D is the depth. So BD cube by 12. Right. So if it is BD cube by 12, then what happens? If it is BD cube by 12, then you have to find out what? That moment of inertia. Now look, in that figure it is an eye. Yes or no? If it is an eye, then it is made up of what? 3 figures or 3 rectangles. So you have to find out the individual moment of inertia of all these 3. Then you'll have to find out, individual moment of inertia of all these 3. Now then you can just find out what? The area. And after the area you have to find out the h. That means what? IAB equal to IG plus AH square. Now IG you know how to find out, that is the simple formula BD cube by 12. Now that means what? That is the moment of inertia of that particular figure about the what? About the center of gravity. Okay. Please don't give the attendance now. After some time you give. I'll say you when to give. So if you find out the moment of inertia, can you see this I? Students, can you see this I? Hello, hello. Can you see this I? Hello, hello.
Yes, sir.
दिखाई दे रहा है तुम लोग को?
Yes, sir.
Yes, sir.
ठीक है. अगर प्रॉब्लम नहीं दिखाई देता है तो बोलना हाँ मुझे, जब मैं नीचे जाऊंगा. ठीक है, मतलब समझा? If you are seeing in this figure I, so there is 1, there is 2, and there is 3, right? If there is 1, 2, and 3, what happens? Now here you have to find out what? Ig for individual things, right? So Ig equal to BD cube by 12. So B is 60. 60 into 20 cube by 12. So you found out Ig. Now you'll have to find out what? The distance of the center of gravity of rectangle 1 from x-axis. So how will you find out the center of gravity of 1? Look, if you see the figure 1, so its center of gravity lies in what? 20 by 2. That means it at half, right? So that distance minus what will happen? That is the distance, and you know the center of gravity of the rectangle is 60.8. So it means what? This 130 minus 60.8 will be what? H1. So you put in the formula Ig, IAB equal to Ig plus AH square. So you will get the answer. Okay. So in this way, you'll have to find out for the other two also. You just try it out. If you can't, we'll just discuss in the next class. We'll discuss in more elaborate manner. Today there is severe issues of network. There's having okay.
ERB is not updated, sir.
The network is very bad.
Hello, sir.
Yeah.
Sir, we
होगा?